Hello everyone, let's have a discussion on curl of a vector. Circulation of a vector field around a closed path is specified as curl of the vector. Mathematically, it is defined as curl of a vector field F is defined as del Sn. This del is very small area. This denotes very small area enclosed by the line integral in the normal direction. As del Sn tends to become 0, you should distinguish the del quantity used to describe differential area with respect to del operator. Right? Look at that. This is the ratio of line integral of f dot dl with respect to del Sn, where del Sn is an area enclosed by the line integral. The line involved in the integration in the normal direction. Okay. The maximum circulation of F per unit area. Circulation of rotation of F per unit area. Is the quantity. As area tends to become 0, the curl is defined. Mathematically, del cross F. Look at that, this is a del operator. Del cross F is the notation, curl of a vector field. Curl indicates the rotational property of a vector field. If the curl of a vector is 0, then the vector field is irrotational. If in any case, if you identify del cross F is equal to 0, it indicates that it is irrotational. Irrotational. Which is irrotational? F is irrotational. So, del cross F in various coordinate systems described as del cross F is equal to AX, AY, AZ. There are three basic primary axes: rate of change of the quantity with respect to x, rate of change of the quantity with respect to y, rate of change of the quantity with respect to z. Since it is taken in the Cartesian coordinate system, fx, fy, fz will be there in the representation, where f is equal to fx into ax plus fy, ay plus fz, az. Cartesian coordinate system. Similarly, del cross F is equal to, in cylindrical coordinate system, A rho A phi and A z. Three primary axes: rate of change of the vector field component particularly along rho, rate of change of the component along phi, rate of change of the vector component along z axis. So F rho into F phi and Fz. Please understand one thing: when you find out derivative of dou by dou r or dou rho of rho into F phi, if it arises, this rho cannot be taken outside, because you will think that it is a differentiation with respect to rho. But rho F phi is to be treated as the component to be differentiated. I'll explain it. Whereas in spherical coordinate system, del cross F is given by 1 by r sin theta dou by, or I'll put it in the same manner, in the form of matrix determinant. So there are three primary axes: r a phi, r a theta, and r sin theta a phi. Right? You can find out that dou by dou r, dou by dou theta, dou by dou phi. So you will have fr component, r f theta component, and r sin theta f phi component. Okay. R theta phi spherical coordinate system. just look at the second component, r is involved. So here also r is brought in picture. Similarly, r sin theta, here also r sin theta, and in the front end you will have 1 by r squared sin theta. Right. So del cross F, which defines the rotational property of a vector field in this manner. Because when you look at the physical significance of, for example, curl is a closed line integral per unit area. Closed line integral per unit area. That is the definition. As the area shrinks to a point, this will result in curl of the quantity. If I say A is the vector, so A dot dl will be taken into picture. Or if you say, for example, curl F, then this will become F dot dl. So closed line integral of a vector quantity per unit area as the area shrinks to a point. It indicates the circulation of the vector field per unit area, circulation density of a vector about a point. I can even quote this as circulation density, the amount of rotation, circulation per unit area of a vector quantity. The vector quantity is F, for example, in this case, about a point. How did you find point here? As the area shrinks to 0, it will become a point. Initially it looks to be an area, but the differential area as it shrinks, it will become a point. The area is going to shrink. Curl of a vector at a point quantifies the circulation of a vector around the point. Circulation of a vector around the point. In general, if there is no rotation, there is no curl. It is said to be irrotational. That's it. There is no curl. While larger angular velocities means greater values of curl is present. So the curl gives you the direction which is along the axis through the point at which the curl is defined. Curl gives you the circulation density of a vector about a point or around a point at which the area is going to shrink. Okay, the curl gives the direction which is along the axis through a point at which the curl is defined. So in general, magnetic field lines, image field lines produced by the current carrying conductor, produced by a current carrying conductor will be rotating, circulating in the form of concentric circles. Roughly speaking, if I say the current carrying conductor is situated like this, obviously the magnetic field lines will be in the form of concentric circles around it, around the conductor. There exists a curl of magnetic field density which has been defined as del cross H. Direction of curl is along the axis about which the rotation of the vector field exists. Direction of curl is along the axis about which the rotation of vector field exists. Proper direction can be obtained by right-handed screw rule. Right? For example, the water velocity in a river, which increases linearly towards the surface. The magnetic field lines due to current carrying conductor, the body rotating about a fixed axis are few examples of a curl. The curl of vector field exists, then the field is said to be rotational. If the field becomes irrotational, the curl vanishes. So physical interpretation of a curl is about a rigid body rotating about a fixed axis. About a rigid body rotating about a fixed axis with a uniform angular velocity. So if V is its linear velocity, then its angular velocity will be omega. So V represents net rotation of a body about the axis. There are different types of curl. For example, If H is rotational, curl of the vector field H is 0. There is one more type of field called solenoidal. We have already told you del dot H is equal to 0. If del dot H is equal to 0, then we say that it is divergentless. It is said to be solenoidal. Solenoidal. So, for a solenoidal field, it has neither source nor sink. That we will discuss later. See, there are varieties based on the results for del dot H and del cross H. Solenoidal and irrotational is one category. If del dot F is equal to 0, then it is called as solenoidal vector field. If del cross F is equal to 0, then F is said to be irrotational. The nature will be it has neither source nor sink. Simply it flows, enters and leaves. Typical nature. There is one more category, non-solenoidal and irrotational. From the previous definition, you would have guessed it. Del dot non-solenoidal, so del dot F is not equal to 0. Irrotational, del cross F is equal to 0. Then you can find out that the arrow marks, it diverges like this. It is expressed as a field that emerges out. Okay, non-solenoidal and irrotational. There is one more category called solenoidal and rotational. Del dot F is equal to 0 and del cross F is not equal to 0. Notice that it is rotational. So when you define a vector field, the vector field will be of this category. Okay. Similarly, non-solenoidal and rotational. Del dot F is not equal to 0 because it is to be non-solenoidal, and del cross F is not equal to 0 because it is rotational. Now we can notice that it looks to be simply can you identify the nature of it? We can quote some examples. For example, I can determine the divergence and the curl of a vector field. For example, A is equal to x squared ax plus y squared ay plus z squared az. You can notice that del dot A, how will you calculate divergence? You will take individual components like the coefficient of ax and differentiate it with respect to x, and the coefficient of ay, and you will find out the derivative of that component with respect to y, and similarly dou by dou z of, for example, z square. So this will become 2x plus 2y plus 2ez. Yes, but if you perform del cross A is equal to simply ax, ay and az unit vectors, dou by dou x, dou by dou y, dou by dou z of x square, y square and z square. You can notice that this is equal to ax multiplied by rate of change of we'll get 2y 0 minus 0, correct. Then ay becomes minus ay, in fact, multiplied by dou by dou x of z squared is 0, and dou by dou z of z squared, x squared is 0, and at last you will get az, which is equal to 0 minus 0. So the total result will be equal to 0. So from this you can notice del dot A is not equal to 0, whereas del cross A is equal to 0. Del cross A is equal to 0. Del dot A is not equal to 0. So it is non-solenoidal in nature, and it is said to be irrotational. Del cross F is equal to 0. there are maximum number of questions from this part, in fact, in the examination. Determine the curl of the vector field. Say, for example, I have a vector field x squared yz ax plus xz az. How will you determine del cross p? Though the definition says it is a closed line integral of vector p with respect to or per unit area, as area shrinks to 0 to a point, about a point. But in practice, we calculate the values based on ax, ay, okay, az, dou by dou x, dou by dou y, and dou by dou ez. And you can notice that it is px, py, and pz. So what is px? You know that. What is py? It is 0. And what is pz? Is known. So px is equal to x squared yz, and pz is equal to xz, and py, of course, there is no component called ay present in the given vector. So I say py is equal to 0. By substituting all these values into this equation, you will find out the answers for del cross p. Similarly, I give you a vector. The vector is q, and it is specified as rho sine phi. A rho plus rho squared z a phi. The last component is z cos phi a z. So how will you calculate del cross q? It is specified as, how will you define in cylindrical coordinate system? I'll give you 2 seconds time, please recall, because in cylindrical coordinate system it is 1 by rho into a rho multiplied by the components. I'll first of all define the first row. Rho a phi a z. And of course it is rate of change of the component with respect to rho, rate of change of the component with respect to phi, yes, rate of change of the component with respect to z. And you will have a rho component, a phi component, but it is multiplied by rho, and a z component. Or I'll mention about this. In particular, this will be represented as, how will you mention it? It is q rho, q phi, rho into q phi, and q is z. Okay, so using this you can evaluate because in this case q rho, what is rho component? It is rho sine phi. What is the phi component of this q vector? It is rho squared z. What is the z component of this vector? It is z cos phi. So by substituting those components into this matrix, you can evaluate the determinant of it and multiply it by 1 by rho to know the final answer, right? Similarly, the last one will be, for example, I just take a vector which is given in spherical coordinate system. It is specified as 1 by r square cos theta a r component and r sin theta cos phi along a theta and cos theta a phi. So you will have dr component, which is 1 by r squared cos theta, d theta, which is equal to r sin theta cos phi, and d phi, which is equal to cos theta. What is the formula to compute del cross t vector? Which is 1 by r squared sin theta, isn't it? And in the matrix determinant, you will have ar, r a theta, and r sin theta a phi. Yes, can you recall? It is rate of change of r component with respect to r, rate of change of the component with respect to theta, the rate of change of component with respect to phi, and you will automatically include r component, and r into t theta. The last one will be r sin theta into t phi. But you know what is tr in this case? We have already given you. What is t theta already given? Or it is known, and t phi is known to you. The previous slide we have written. So tr, t theta, t phi, based on which you can calculate. Similar to this one, I have one more problem. I have given a vector field to you, yz ax plus xz ay plus xy az. You determine, verify whether this vector field is both solenoidal and irrotational. You determine that from the definitions what you have learned already, because you need to calculate del dot E, verify whether the given vector field is both solenoidal and irrotational. You have to calculate del dot E. If del dot E is equal to 0, if del dot E is equal to 0, then you will declare that this is solenoidal in nature. And similarly, you have to evaluate del cross E, and based on the result of del cross E, if it is equal to 0, determine is that 0. If it is 0, as del cross E is equal to 0, you will immediately declare that this is equal to irrotational. There are many such university questions. For example, in one of the question papers, it is specified as f is specified as x plus 2y plus, for example, a into z multiplied by ax unit vector plus bx minus 3y minus z into ay. The third one is 4x plus cy plus 2 into z az. Did you notice one thing? The constants a, b, c are not known to me. So I'll give you a condition. The field is, if f is irrotational, find the constants a, b, c. How will you calculate it? Del cross f, you have to evaluate del cross f. From del cross f, from the given condition, it is irrotational. So del cross f is equal to 0. If del cross f is equal to 0, from each part of it, you have to say whether will you be able to find out the constants a, b, c. For example, I have del cross f, which is identified by ax, ay, az. Okay, because the given vector field is in Cartesian coordinate system, dou by dou x, dou by dou y, dou by dou z, fx, fy, and fz. So you can compute the rate of change of fz with respect to y minus rate of change of y component with respect to z, isn't it? Dou by dou z, dou by dou y of fz, dou by dou z, fz, fy multiplied by ax minus ay multiplied by rate of change of fx with respect to z minus rate of change of fz with respect to x. Similarly, no. In this case, the order is reversed. I'm sorry. If you take this as plus ay, then only you can perform the multiplication of dou by dou z of fx, dou by dou x of fz. So the last one will be az. Az will be having the coefficients rate of change of fy with respect to x minus rate of change of fx with respect to y. So you should understand one thing. If this is equal to 0, yes, what is it equal to 0? Because del cross f is 0 because irrotational characteristics of this vector field. So this is equal to 0, which implies that rate of change of fz component with respect to y minus rate of change of fy with respect to z is equal to rate of change of fx with respect to z minus rate of change of fz with respect to z, which is equal to rate of change of fy with respect to x minus rate of change of fx with respect to y will all be equal to zeros. So from this you will say c minus 1 is equal to 0, which implies c is equal to 1. From the second condition, yes, from the second condition, a minus 4 is equal to 0, which implies a is equal to 4. And from the third condition, I can say, yes, I can declare b minus 2 is equal to 0, which implies b is equal to 2. All the constants have been evaluated. So like this, you can determine the curl of any vector field. Say for example, a is specified as y z ax plus 4xy ay plus y a z is a vector field. How will you calculate del cross a? Similarly, a vector field b is specified as rho z sin phi a rho plus 3 rho z squared cos phi into a phi. You can calculate del cross b from the matrices or the determinants given to you already. Okay, I hope you would have learned the characteristics of curl, which specifies the amount of circulation of a vector field around a closed path, or the closed line integral of a vector field per unit area. As the area shrinks to a point, you can calculate that. Thank you.